All right, problem number 10. With what initial velocity must an object be thrust upward from ground level in order to reach a maximum height of 600 feet? This is a pretty cool problem, I think, actually. Obviously, it's neglecting wind resistance, but that's okay. It's still cool nonetheless. So, maximum height, we're talking about a position function. H of t equals stuff. And remember, if we're talking about feet, we're going to be talking at negative 16 t squared plus our initial velocity times t plus our initial height. Well, since we're thrusting it from ground level, our initial height is 0. So I'm just going to get rid of that. But we want to know, what does our initial velocity need to be? So think about this. If you were to take the derivative of this function, h of t, to get the velocity function, v of t, you're going to get 2 times negative 16 is negative 32 t plus v naught. We want to figure out what v naught is. We have t and v naught both unknown, so we're going to need to use a system of equations. And we're told that the object is going to reach a maximum height of 600 feet. So then we can go ahead and say our height is 600 equals negative 16 t squared plus v naught t. And then this is the tricky part that's hard to see. But remember, when the object reaches its maximum height, for a very brief second, its velocity is 0. So if we look at our velocity function, we can say 0 equals negative 32. Oh, my bad. Not 3t. 32 t plus v naught, where that t and that t and that t are all the same t. So let's go ahead and solve it. I'm going to rearrange this bottom equation as 32t equals v naught. Now I'm going to take this and substitute it in up here. So I'm going to get 600 equals negative 16 t squared plus 32 t times t, which is t squared. So negative 16 t squared plus 32 t squared. I've got 600 equals 16 t squared. Divide both sides by 16. And I get some super funky number, 75 over 2 equals t squared. Take square root of both sides. Square root of 75 over 2 equals t. And when you do that, the positive number that you're going to get, which is the one that we're going to want, is going to be 6.124. Sweet. So that tells us the t value. So the time, the seconds that it reaches that maximum height. Now we need to take this, plug it back in to one of our equations. I'm going to plug it in right here because that's a simple equation. So 32 times that t value, 6.124, and plug that into your calculator, and you are going to get 195.959. And then have we answered the question? Yes, because that is v naught. That's what we wanted. So our function, h of t, if we just write it, because that's a good idea, is negative 16 t squared plus 195.959 t. And you can enter that into your calculator, calculate that maximum value, and you will see that it is, in fact, 600 feet. Sweet! That is a cool problem.